Hey everyone, we'll continue in chapter 5, lines and angles. We're not going to draw anything in this theory, we're actually going to calculate stuff, which does make things a bit more different. And I'll start with two homework exercises actually to introduce you to this topic, exercise 50 and 51. In the figure on the right, you see rectangle A, B, C, D. By drawing diagonal AC, you get two smaller angles at point A. And to indicate which one is which, we can then write in numbers there. So you put a 1 here and a 2 here, which means that if we're only referring to this triangle part right here, or you can say angle A in triangle ABC, we call it angle A1. So it's clear that we only need this part and not that part, and surely not the whole triangle. Angle A in ACD is therefore called angle A2. And if I want the whole angle, so the angle in ABCD, they call it angle A12. Not angle 12. Okay, so angle A12. Write the numbers a little lower than the letter A. You see it here, that you have to write them a little lower. Fill in. Angle C in triangle ACD is angle C ... blank. So is it angle C1, C2, or angle C12? The correct answer here is angle C2, because we only want this part that's part of ACD, because that's what they want to. If we want angle C in the whole rectangle, that means I want the whole angle. So don't just write down angle C, don't write down angle C1 or 2, but it's angle C12, the whole angle now. And if I only want ABC, then it's only the part C1, so angle C1. It's important to notate this clearly so I know which part of the angle I actually need, or I actually want to do something with. Okay? So that's a bit of a notation technical thing. Exercise 51. In the figure on the right, you can see two lines intersecting at point S. They make a sort of cross, right? And this whole point here, or this vertex is vertex S. And to indicate all the separate parts, they call it S1, S2, S3, S4. Why is angle S12, so this part right here, why is that 180 degrees? Well, if I would just leave out this line segment here, or this ray you could say as well, then you see that what I'm left with is an angle over a straight line. So if I would now flip from my this thing, if that's me, if I go back to pen notation, if I take a look at this part right here, that's an actual straight angle. And we know that straight angles are 180 degrees from a few theories back. You can see that angle S1 is 50 degrees, but do I then also know how big angle S2 is? Well, actually we know, because I just showed you that angle S12 is 180 degrees. If together those two angles are 180 degrees, one of the angles is 50 degrees, that means the other one, S2 in this case, must be equal to the full angle, 180, S12 I'm referring to in that case, minus the part that I already know, so angle S2 is 130 degrees. And you can do the same for angle S23. If I know S23 right here is a straight angle, then that's 180 degrees. And that means that if I know it's 180 degrees, then angle S3 is 180 minus 130, because remember we knew that this one is 130 from B. That means this one is 50. 180 minus 130. And at D they then ask you, well, how big is S4? Well, if you again follow the steps, you will find this is 130. And this is also 130, following from B. And this one was 50. And you see something fun happening here. Well, fun, it's mathematics. You see that the two angles that oppose each other, de twee hoeken die tegenover elkaar staan, that they have the same value. They both, S1 and S3 are 50 degrees in this case, and S2 and S4 are 130 degrees. That gives us quite a lot of information. That means that if I know S1, I can immediately say what S3 is. I don't have to go through the motion here. And vice versa, if I know S2 or S4, I know the other one. And we're going to use tricks like this in Theory A to calculate with stuff. Theory A, they call it opposite angles. They say that, well, if you have intersecting lines like this, and I'm now going back to my laser pointer, it's a bit more clear. If you have intersecting lines like this, that means that the sides that are opposite to each other have the same size. So the circles here or the crosses here have the same size. That's also what those symbols indicate. Those two crosses and those circles indicates, hey, those two angles have the same value. What angle it is right here doesn't matter right now, but they are the same. For example, 20, 20, 160, 160. And this man here, Euclid, is the one who did a lot of work in these fields of mathematics. If you find it interesting, this part is in your book as well. Normally I will be going a bit more into depth into my lesson about this, but now it's an online video. I won't do that for too long. This man is actually very important. He did a lot for geometry. He also one of the first ones to write down actual proofs, general proofs, how he came to rules like this. But alas, let's carry on. What we're going to do is I'm going to give you a random configuration of lines with some information, and I'm going to ask you to use that to can calculate others or sometimes all other angles. And it's important to then know which rules we can use. If it's ever given that you have a right angle, then that angle is 90 degrees. If it's ever given to you that you have a cross formation, so two lines intersecting, then know that opposite angles, de overstaande hoeken, have the same size. And do remember that a straight angle is 180 degrees. And you see me putting emphasis on this. If you ever make a statement in geometry, dus als je een berekening of een statement maakt in meetkunde, geef je met haakjes aan welke regel je hebt gebruikt. This is very important. If you decide not to do this on the test, I decide not to give you full points. So please do. So again, what can we expect? Let's take a look at this example. They give us angle A1 is 42 and angle A3 is 90, and they want us to calculate A2, A4 and A5. Generally speaking, I would say follow the order that the book wants you to do stuff. That's not always necessary, but sometimes that gives away the order that is the easiest to do. That means that here we would first focus on angle A2. And they say here that angle A123, that one right here, so that means this one right here, is a straight angle. That means angle A1 plus angle A2 plus angle A3 is 180 degrees. And if you make that statement, write it down, straight angle. What does that mean? Well, I know angle A1 and I know angle A3. That's 90 degrees. That means that angle A2 must be the part that if I add everything up, it becomes 180. So that means I can calculate A2 by taking 180 minus 42 minus 90, so this is A1, this is A3, is 48 degrees. So angle A2 is 48 degrees. They notate it like this, so don't forget to put your rule right here. Sometimes I see books putting the rule right here as well. This is enough. I must find it somewhere in your calculations that you have assumed a straight angle rule somewhere. That's A2. And believe it or not, I think angle A4 is maybe even easier. You can do this in multiple ways, I think, but I hope the book does the easiest one as well, and luckily they do. They say angle A4 is angle A1. again, if you want to, I can draw that. Makes it maybe a bit more clear. Let's take the pen. And what you see here is that those two lines here make the cross, right? So that means that this angle must be equal to that angle. And that is what opposite angles are. And then I can immediately say angle A4 is angle A1 is 42 degrees. Don't forget this rule, opposite angle. Okay? And then again, A5 you can do in multiple ways. I see sometimes people saying, well, I now know all the angles so that except A5. So it's 360 minus this one, minus this one, which is 48, minus this one, which is 19, minus this one, which was 42, which is totally okay. I see some people working with a straight angle rule here. That's what I put in green here. If you know that this here is the straight angle, so it's 180. And you know this one is 42, it's 180 minus 42. I think this is the easiest one actually, the least arithmetic. So that's why I added this, because the book takes a different way. They say, well, angle A5 is the same as angle 2, 3. And I'm going to draw that in as well for the people who don't see what's happening right there. They say. And again, that's why I would always give you the tip to, if you do this on the test, draw on the test paper with colors and make those lines that are intersecting clear, because that makes it a lot easier to see which angles are actually opposite to each other and which aren't. And you see that angle A5, that's indicated with this cross here, actually is the same not to A2, not to A3, but to A3 together. And that's why they say angle A5 is angle A23, which is why they do 48 plus 90 is 138. And then they use the opposite angles rule. The way I did it, I'd use the straight angle rule. And that's something we're not that used to yet, but there are actually multiple ways to do this. Always lead to Rome, they sometimes say. And I don't care which road you use, but do write down which rule you used. So either use this one, opposite angles, or write down straight angle. Or if you really want to, you could have used the full angle. Then I would put full angle here. The book never uses that, so that's why it's not one of the rules. But then you would 360 minus all the other ones. But write down your rules, please. It's very important. It's so important actually that I've added an extra slide with that. Always write down which rules you've used inside of brackets. So here's this stupid meme here, writing down used rules, error calculations, or draw 25. Some people rather draw 25 cards than that they actually write down the rules. Yeah, you do you, but then do know that you missed out on a lot of points on the test for something you actually know how to do, which means you're doing something that's really not necessary. Write down those rules inside of brackets, please. And even more important, and that's why I find it so important that you write down the rules, is then I know what you have done. If you don't write down the rules and you don't write down your calculations, that's here it says calculations as well, right? You see that happening here as well. Write down your arithmetic, write down your steps. If you don't do that, I don't know if you actually calculated it. Maybe you just measured it. And when the exercise says to calculate the angle, you are not allowed to measure it. That means that if you measure it, you get 0 points. Or, as they say here, measuring when you should be calculating, then I would say that that is worthless. And that means it's important to write down in between the brackets what your rules are, and also write down the calculations that you made, because that indicates to me that you're not measuring. Okay? Oftentimes it's very easy for me to see when you measure it, because if you measure it, then you're oftentimes 1 or 2 degrees off, and then I don't see any rules and I don't see anything. So then I can immediately say, 0 points. You are not allowed to do that. Okay? So yeah, just start practicing. Maybe I will upload another example of one of the homework exercises on, in video format as well. Then take a look at that one as well if you find this difficult. Bye!